Welcome to The Machine, a computer science education podcast from the South East Technological University of Ireland. My name is Rob O'Connor, a lecturer from the Department of Computing and Mathematics at SETU. This episode is a cross-posting with our sibling podcast 9+, which I also host at SETU. The subject matter kind of fits both podcasts, so I thought I'd get a 2-for-1. If you like what you hear, you might want to also check out 9+. It's not just computer science talk. We cover a whole range of academic disciplines over there. I find all of them interesting, and maybe you will too. Look for Digit 9+ wherever you get your podcasts. Anyway, I had a great chat with researcher Dr. Indrakshi Dey about autonomous systems, leading into a discussion about AI and how we tend to anthropomorphise computer systems of this kind. And that came out of a recent showing of Stanley Kubrick's 2001 that I attended, where Indrakshi was part of a panel discussion afterwards all about AI. Obviously, Hal from 2001 being one of the most famous AI characters in popular fiction. The conversation also delved into Indrakshi's position as a woman of colour in a male-dominated sector and how that gives her valuable insight on things. I found Indrakshi to be a very engaging and a very, very funny guest at times, and personally, talking with her pushed me a little further down the road of understanding with respect to AI. So, without any further waffling on my part, here's Indrakshi Dey.
Hi everybody, I'm Indrakshi Dey. I head a research division called Programmable Autonomous Systems at the Walton Institute for Information and Communication System Sciences at South East Technological University, Waterford.
Okay, so Programmable Autonomous Systems, PAS. We'll start with a big one. What's that?
Right. So let's break it down into words. So first of all, let's take the last word, which is the simplest one, that's systems. What do you mean by a system? A system can be anything from a coffee machine to a car, to a aircraft, or even a missile, right? So any system. Now, that means we design systems, but systems that are electronic systems, not... for example, we cannot really design a forklift, for example, or we don't really work in designing trucks. So whatever electronics that is involved in that system, that's what we work on. So, for example, how the car moves or the mechanism behind a truck moves, or how do we control an aircraft? That's what we deal with in terms of systems. Now, let's go to the second word, that's autonomous. Autonomous means a system should operate on itself without any human intervention. And that's what we are trying to do. How do we make self-driving cars? We have autopilots in aircrafts or any system. Nowadays, we are designing robots to do different kind of activities that are really very difficult or laborsome for human beings to do. So, for example, we recently worked on a proposal that we wrote for the European Commission, where we are trying to assist labors in agriculture. So, for example, you have to, let's say, cut flowers or repot lettuces. So it's something that is a very, very mundane job. It's a kind of a drudgery if the weather outside is very, very bad. Now, how do we help agricultural laborers in those cases? A robot can go outside when it is raining very badly, and a person cannot go out and cut the lettuce. So that's what autonomous is about. And then programmable, that means, of course, when you develop an autonomous systems, you also need a central control or a distributed control somewhere so that you can incorporate autonomy to the system or to the machine. So that's what PAS is, or Programmable Autonomous Systems is. Okay,
so if I could sort of summarize it, I'm going to say things, just because it's a nice word, okay, and it covers a lot of, it's a fairly all-encompassing word. Things that can do stuff themselves, but we have a degree of control over.
Yes.
Is that fair enough?
Yeah.
Okay, now that's a very broad term, so we might delve into that a little bit more. I remember talking with some agricultural researchers from Walton a number of years back. Or it could have been last year, it could have been 2 years ago. Time has no meaning. It all falls away. And they were talking about a robot in an agricultural sense that could go into a field and pick a strawberry. Yeah. And there are a number of challenges associated with that. So the first thing is, okay, the robot has to be able to move. And you don't want to just be remote controlled because that defeats the purpose. It has to be able to move in unbalanced terrain. It's not a road, so it's not perfectly flat. It also needs to be able to detect a strawberry,
yes,
as opposed to something else that's red, or equally, a stone or whatever it might be. And then it needs to be able to safely pick a strawberry without crushing it. So that means it needs to apply a certain amount of pressure, a certain amount of force, not too much, but equally not too little. So there's a lot of things going on there. And I mean, there's also navigation. There's a whole load of other problems associated with an autonomous system such as that. So based on your work that you're doing so far, where in those kind of gamut of things, where do you sit? Or maybe it's none of them. Maybe you do something else entirely. I don't know.
No, we sit on almost everywhere.
Okay. Okay.
Yeah. So definitely we don't work on designing the robot itself. So for example, a robot can be made up of metal plates, right? Or a robot will need also a camera to locate where the strawberries are, right? So we don't really work on designing those metal plates or how they will be put together to make a robot, or how the camera will be fitted into the robotic structure so that it has the best visualization. However, anything that is on the soft side, like how the robot will move, how the robot is going to detect whether it's a strawberry or not, it has to be very, very precise in its movement. It has to be very, very precise about its environment too, like where it is walking around, whether it needs to walk always on the straight line or there are ways that it needs to waver around and detect. So all this control on the softer side, that's what we work on.
And right, so I have a couple. Last year, I think it was, we bought a robot vacuum cleaner for the house. That's great. And I'll be honest with you, because I'm a big nerd. The first time it went off, I was almost following it around, and I was also, it came with an app, and I'm watching it map the house in the app, and I was kind of fascinated. I was trying to figure out the algorithm that it had to finding its way. And I'm not 100% sure. Like, it wasn't just turn right and keep turning right. I'm not sure exactly how it worked, but it does work. But what kind of strikes me about it is every now and again I'll say, oh yeah, I must send off the robot. So I send off the robot, and then I get a note on my phone to say, oh, it's got stuck or it's got caught on something. So on a piece of consumer technology in the home, it can fall down very, very easily in a relatively safe space of a home. So I can imagine in a field or in a factory or in any sort of environment, there's a number of, if I say existential threats to a system, I hope I don't mean in a kind of the world is falling, but there's a number of obstacles that it may have to overcome. And I wonder how you, as a researcher, try to anticipate those.
Yes, we call them research challenges.
Okay, that's a much more eloquent way of putting it than I did.
Right, and so there are two things. We always consider everything as a system, as I mentioned even before. So let's say we consider the robot as a system. The robot doesn't look like a human being. It can be of any shape or any size, depending on the purpose. That's And that's one part of the design. That's like the mechanical design. We don't deal with that. What we deal with is basically what is the work or what is the aim of the robot or what is the purpose of the robot is for. And the second thing that we deal with is what is the environment that it will work on. Is it an external environment? Is it a rugged terrain? Is it a smooth one? Is it an indoor environment? So in any system, design depends, first of all, on the aims or the purposes for which the system is built, and also considering what environment it will work on. So together, we parameterize those two things. So we have a set of parameters for its aim or purpose or work, and we have a set of parameters for its environment. Now we try to, I think, what the best word to summarize, and it's a huge field of mathematics itself, is optimization.
Yeah.
So how do you optimize these two sets of parameters so that they can work together in the best possible way?
Yeah, and it also has to be, in the case of a robot, a physical robot type system, it all has to be on board as well, I'd imagine, because you can't rely on computation being conducted elsewhere. You know, or maybe you can to a certain extent if it's networked, but also you probably have to account for the case where the robot is left on its own.
Yes.
How will it manage in a situation like that?
Yeah. Now, systems never operate alone. So,
Okay, yeah.
So before it used to be centralized, controlled. Now we are gradually moving towards the area of distributed control. It's easier also because the computational task gets distributed too, right? So what is distributed control? It means a half of the work is done on the robot itself, while 50% of the work is done somewhere else, like a hub or a gateway.
Okay,
So there is always a controlling center or a gateway or a hub. And at the same time, some of the decision making, some of the optimization is done on the robot itself. So it's never just one unit, because we also need to take care of the situation where the robot can fail, right? So if it is a standalone system, what will happen if the robot fails? There will be no way even to know that the robot has failed. So you need a central information center somewhere to at least know that the robot is malfunctioning. It's not working properly. So, yeah.
No, I think about kind of the more extreme example of that would be like, you know, the is it the Pathfinder or the rover on Mars?
Yeah.
You know, there was a case a couple of years ago. I'm probably getting the details wrong, but you know where it just started disappeared. They didn't know where it was, and they kind of had to rely on its own internal systems to be able to find its way back so that it could communicate centrally again.
Yeah. For example, if they call it self-healing.
Okay, right, yeah.
And it's like if you have a problem, how do you heal yourself without relying on the gateway or the control center? For example, if the link between the control center and your system breaks. So there is no way of sending information back, right? Or even before failure, like sending an alarm. In most systems, it does send an alarm, but if the link breaks or if there is no way that you can actually gather that information, or even the gateway can malfunction. So we always we are trying more and more as we develop autonomous systems to put in a functionality of self-healing there so that the system can take care of itself when such things happen. And again, it's a huge area of optimization, predictive estimation, what things can happen and how to, or what are maybe providing a list, checklist. If this thing happened, then you should go to this. Or maybe if you have a failure A, then you should always resort to system B, something like that.
I'm thinking of that quote, physician, heal thyself, and robot, heal thyself. It's maybe not quite as poetic, but it might be an interesting opening line for a short story. Okay, but as we're describing these things, so you're talking about the context that a lot of your work is in agriculture. Am I right in that?
No.
It's not just that. It's across the board. Okay.
Yes, it's across different verticals. So we don't care about the vertical or the application. By training, I'm a basic researcher, not an applied researcher.
Actually, right now, before you go any further, can I get you to explain what the difference is between a basic researcher and an applied researcher is?
Right. So,
because what I'm thinking of is maybe there's a student who may not necessarily know the difference.
Sure. So a basic researcher is somebody who tries to solve problems or build new tools rather than looking at the application that they are suitable for, right? So you build a basic foundational tool or you solve a foundational problem, and then you take the solution and modify it based on the vertical or the application that you are serving. So the same kind of tool can be used for solving some problem, let's say for health, and the same set of tools can be used to solve a problem in transportation. We need to tweak or we need to modify the solution to suit the application or the verticals that we are serving. While an applied researcher is somebody who works just based on the applications or the solutions that he or she provides, or the tools he or she develops will just be catered to that particular application. So
if I can try to summarize this as an example, calling back to what we were talking about earlier, a basic researcher might be concerned with computer vision interpretation, which is how a computer system might form a model of objects based around what it sees through the camera. Whereas the applied researcher then in the strawberry example is going, right, how do I pull out a strawberry from that picture? Would that be fair enough-ish?
Yeah, kind of. Yeah.
Okay, kind of. No, please correct me if I'm wrong.
No. You are almost there.
Okay, yeah, good enough. Good enough for jazz, as they say. Okay, so to change tack a little slightly then, because you're also involved with the Connect Centre. Now, what's the Connect Centre?
So the Connect Centre is basically an SFI, Science Foundation of Ireland, funded research centre that spans across 10 universities. I think in recent years they have also added some more colleges also and technological institutes also into the centre. But it's more like collaborative. So it's whenever we talk about Connect, and I'm often corrected by the admin people in Connect that...
I know that feeling.
So this is not a public service body. So it's not an entity itself, but it is a collaborative effort, you can say, to bring together researchers who work in the area of networks, in the area of telecommunications, and how we can bring everybody together, bring in complementary expertise to solve different problems that we have. Yeah.
Okay, so again, if I was to think about that the way you've described it, it's a huge portion of, in my limited experience with science and technology and all that, all the best and most interesting work is done through collaboration.
Yes.
And it seems like the way you're describing it, this is a vehicle through which collaboration and communication can occur between various people involved in that area in Ireland. Would that be fair enough?
Kind of. So let's go back to that example of a robot.
Yes.
Yeah. So as I mentioned, we worked on the softer side. We work on the algorithms, while we need some expertise also who develops the real electronics, the components, electronic boards or the chips that go into that. So, for example, Tyndall National Institute can come in there because they work on chips, on integrated circuits that incorporate these functionalities. So if we are designing a robot, so let's say Walton Institute and Tyndall would work together to develop this robot. So
okay, right, yeah. So I can see where that comes from, yeah. I'd like to change tack again and talk briefly about artificial intelligence, because a day doesn't seem to go by when there isn't some mention about AI in some respect or another. And I'd like to go back a few months. Science Week in Ireland, I can't even remember when it was a few months back anyway, and in Garter Lane Arts Centre in Waterford, Calmast, the group, they put on a showing of Stanley Kubrick's 2001. Very famous film from 1968-69, I think, and it has probably one of the most famous AI characters in the HAL 9000 computer is in it. Afterwards, there was a panel discussion of which you were on the panel, and it was fascinating. It was great. I really enjoyed it. To kind of hit you with a bigger question first, how much do you think the science fiction of AI matches up with the reality of AI?
10%.
Okay. I like the way you put a figure on it. Okay. In what respect?
Because now AI is a very, very broad term. So it's, if we again break AI into words, it's artificial intelligence. So basically, if you incorporate autonomy, if you incorporate the functionalities that we were talking about just before, self-healing, into something, it automatically brings in intelligence to the system. And any system that is not natural is artificial. So it's a huge term, and it's a huge umbrella to describe so many different kinds of tools, different kinds of enabling techniques that and people generalize it or by comparing it with things like ChatGPT. Now, recently, I honestly, I also use ChatGPT sometimes.
That's okay. We all admit it's fine. Exactly. There's no problem.
And I love it because, as you mentioned, you are a nerd. I'm a nerd too, so I try different tools that's out there, right? So recently, I also started using Google Gemini AI.
Oh yes, yeah.
So that's another tool again, and sometimes I even compare their responses to a particular question that I'm asking them. Now, people generally just relate to ChatGPT or Google Gemini as AI, but they are merely just a very, very small corner of what AI is or what it encompasses. So
I know what you mean. Like so AI is a broad circle, okay, or space, and the large language models are just a small, tiny portion of that. But I suppose they've become very, very visible. It's like the tip of the iceberg that's peeking up, and people can see it. So that's maybe why it gets a lot of attention. And just this is something I'm grappling with at the moment, and I'm trying to form my own thoughts about it. But like we, as in people, we often kind of anthropomorphise these things. Like we seem to project ourselves onto it, and I'm just thinking of the way even some students or people have described, or not students, have described the likes of ChatGPT or Gemini or Bing or Copilot, or whatever they're calling it this week. They'll often say, oh, well, ChatGPT said this and ChatGPT did this. And it's almost like implying that ChatGPT has some sort of agency in itself to do things. And And I wonder, is that maybe just because they communicate to us in a language that we recognize, in a human natural language, as opposed to, say, computer code or just raw data. And I don't know what the answer is. I don't even know what the question is, to be honest with you, because I'm still trying to form my thoughts. But what do you think about us projecting our own thoughts and feelings onto these autonomous systems?
Right.
It's a tough question. I don't even know if it really is a question, to be honest with you, Indrakshi. So you can just interpret that any way you feel.
I sometimes think about it as just projecting yourself on your child. So I'm a mom. So when my child was born, and it's all from my experience that I'm talking about. So when a child is born, it's like he or she is a clean slate, right? So she picked up the language that we generally speak among us as parents in the home, right? And that's how a child gets trained in the mother language, or the language that is spoken most often in a household. It's just the same for the large language models that we have in form of ChatGPT. We kind of, or when it was developed and as it is getting developed, we kind of curate it with the language that we are familiar with. That's why it talks back to us in a way that is familiar to us. I don't know whether I answered that question.
No, it does, yeah. No, it absolutely does, because it's not really a question. It's more of a kind of just a ill thought out statement. but right, again, I'm going to change tack ever so slightly, and because so you're a woman. That's not news to you. Okay, and I'm thinking a lot in the last few weeks because we have a Women in Tech event coming up. It's International Women's Day. There's a massive gender imbalance in computing, and as well as that, you're also a woman of colour. So you're kind of doubly unrepresented in, if I say the computer industry or the technology industry, that's a very large nebulous thing. I mean, if I look at the likes of me, I look at the computer industry, it's full of people who look like me. Okay, maybe they don't have as many freckles, maybe they don't have untamed curly hair, but they look like me. There aren't as many representative role models for somebody like you, or maybe there are, and I'm just not aware of them. What do you think about that? Of course, there are, obviously, but in popular culture, in part of the popular consciousness, it's, if you ask somebody to describe a computer scientist, they'd probably draw somebody who looks more like me than like you.
Yes, absolutely. And I have lived in many different countries. Nowadays I don't really see differences between nationalities and culture. I have lived in so many places because I found human psyche is quite similar if we delve a little bit deeper than just being a tourist. So I see that. I can give you examples. So, for example, maybe almost like 7 or 10 years back, we were, myself and my husband, we were hiking in Alaska. And we came across a gentleman, an old elderly gentleman, and he was just following us on the hike. It was quite empty, and myself and my husband, we were discussing in our own language, what will happen to these glaciers in a few years? They will be gone. We were seeing receding ice fields, even in Canada. We see that quite a bit. And so what will happen? And that person kind of was I think he picked up some of the words. So he kind of came over and asked us like, oh, what you were discussing. And we said, oh, we were discussing this, and it's so beautiful because we were hiking the Exit Glacier. I don't know whether you know about it, and the Harding ice field. They are close by. Okay. So, and then this gentleman said that, okay, you know what? I'm a climate scientist, and I'm from University of Utah, and we have been working on this, and you guys are so... and it was 10 years back that I'm talking about. It's not now. So you guys are quite right what you are thinking about, and this is quite coming up. And then we kind of discussed quite a bit, and then he asked my husband what his profession is, and he said, I'm an electrical engineer, and I work all across Canada and US. And then he suddenly asked me, so what do? You take care of him?
Oh, wow. Okay.
And travel with him.
Did you produce your PhD from the University of Calgary?
I said, yes, I do take care of him because I love cooking. So, but I also work for, at that time, I just had finished my PhD at that time, and not finished my PhD. I was in my final year, I think third year or final year of my PhD. And after that, I was about to join on a project for the Defense Agency of Canada. And right. And then I told him, no, not me. I think my husband told him, no, I think she is brilliant, and she is working on her PhD. And the guy was completely shocked because he didn't think that this could happen. So even coming from an elderly professor and a scientist, this was quite odd to see me. So I do understand that how misrepresented and how lowly represented I am in terms of that. Yeah.
Well, I mean, even by doing this, you're hopefully moving the needle along for those coming behind you, if you know what I mean. I'm not trying to put the weight of the world on your shoulders or anything like that. But so on that topic, I mean, is there anything that you like? So let's go back to Indrakshi Dey as a young person. Okay, not that I'm not as a girl. Okay, what got you interested in all of this in the first place? So what sparked your interest in science, technology, engineering?
I loved science.
Okay.
I wouldn't have been an engineer, maybe, but okay. I used to love physics, or from the very beginning I started studying physics. Why? It's because what physics does is basically you see natural phenomena happening surrounding around you. Sorry, I'm losing words. So
you're very. Don't worry about that. I've lost plenty.
So, and what physics does is basically, and that's what physicists do, find out rules, laws that govern the natural world around us and explain why things are happening like that. So it's that's what sparked my interest all along. And of course, I chose to go through engineering because that was closest to physics. And sometimes when you are young, you are sometimes pushed by your parents that, okay, this is a better choice of career. If you study engineering, then you will end up earning, I think, billions of dollars. So you should go for it rather than being just a physicist. So I took engineering, but right after engineering, that's why I didn't stay in the field of just working as a software engineer or a technologist. I moved on to do my master's and then my PhD, and more I studied. I went into research. I I started learning more and more about the physical phenomenon that governs all the things that is happening around us. And it was good that I was trained as an engineer, because I now find that we can use those laws to design system that can help us in turn. So, yeah.
And so you said your family is Indian originally, is it?
Yes.
And but you grew up in Canada, was it?
No. So I did till my undergrad, I was in India. So
Okay.
I did my engineering from there. Then I moved to UK.
So you did a master's in Southampton, isn't
Yes,
that right? Yes,
yes,
okay.
yeah.
And then you moved to Canada.
Yeah. And then when I moved to Calgary, it was just a family choice. My husband got a very good job. And so, yeah. So we gradually moved there.
Okay, and now you're here in in the southeast of Ireland. What's kind of, so you said about how you've built up this perspective and experience over the years. I can totally see how it is, because you're straddling multiple continents and getting different viewpoints from lots of different lived experience. Based on all of that, is there anything you think that we can do? And I say we as a society, or as educators, or as whatever you're having yourself, to encourage more young women to become involved in technology, science, engineering, all of that?
I think it's more about role models. So as kids, you are always confused.
Yeah.
So and there are so many different things that is happening around you. You have your friends to influence you. You have your parents to influence you. You have your, let's say, elder neighbors, everybody, your teachers, and all of these create a set of role models that we tend to follow until we kind of have a definite idea what we want to do exactly. Now, while we are growing through this, what happens as a woman, what I found is the lack of role models. I barely see any women around me when I was growing up who is working in technology, who is working in science, or rather even working.
Yeah.
And also going even out of your city, out of your country. I was the first person of my family to go out of my city. I grew up in a very big city.
Wow.
I don't know if you know about Calcutta. So
Yes, yeah.
I was born in the middle of the city. So I am a very, very city girl. And I did have a great exposure in terms of education and school. I went to very good schools, and whatever I am or as a personality, I think 95% came from school and university that I went there. And it's just those lack of role models. In school, when I was studying, all my teachers are female. While as I moved to university and as I started studying science, all my teachers are male. So it kind of that's what I see. And it's as I mentioned, anybody left even the city. So given going out of the city, going out of the country, or maybe having a global experience, those things, it's barely seen around you. And as a kid, it's difficult, that's why, to relate. Nowadays, when I grew up, there was not such an exposure to internet. However, nowadays we do have that exposure. I came I became familiar with internet or even computers like when I was in, I think, grade 7 or grade 8. But nowadays you have those information out there, but you still get stuck with the role models that you see around your friends. If you see all your friends, all the girls who are besties are moving to arts or doing social studies, you would also tend to do that, right? So it's all about creating role models. I think the more and more if we can create role models, the more it, yeah.
Yeah, and the positive impact that you can have on the world in general, I'd say, because not just you, but also people like you and anyone working in this industry. As I looked up your profile prior to this podcast recording, I saw that there was a special section that was set up about how your work is impacting on the UN Sustainable Development Goals. And it specifically links it to three of them, which is good health and well-being, affordable and clean energy, and also sustainable cities and communities. I mean, all of the goals are obviously good, but I don't think anyone can say, oh, well, they're bad things, or they're not going to have. If you can move the needle on affordable and clean energy, well, that has to be a positive contribution to the world.
Yeah. It has to be, and the way we are moving, like if you look at the projections, politicians, I'm completely apolitical. I barely follow any news or this kind of things.
Good.
But
and your mental health thanks you for it.
So, but I hear because when my friends or colleagues tell me, oh, this politician said this and this, and climate change is all bullshit, and we don't really see this changes happening globally. I would always tell everybody, and I could see it in. I did see the evidence if you go back to Calgary. So it's Calgary is situated very close to the Rockies, and it's also around 150 kilometers from the Columbia ice field, which is the birthplace of many of the river chains that feed into the Arctic, the Pacific, and the Atlantic.
Oh wow!
And that's a geographical wonder, that entire area. So in 2011, when I traveled there for the first time, I saw the Columbia ice field receded. Like they have marks every year. They put a mark like how much the ice field is receding. So from 1980 to 2011, they have a mark. It's like across 2 lanes on the highway, right? So, but when I went back, like in 2021, I again went back there, like after 10 years, the amount it has receded, it's unimaginable. You can see it. It's like almost equal to the amount it has receded in the past 30 years. So
wow.
It's so you can see that, and it's difficult to see that everywhere. If we are lucky that we live close to those kind of very geographical areas that are birthplaces to many freshwater chains, many things. So it's difficult to see that everywhere, but you can see that there, and it's shocking. And after seeing that every time, it pains me, and I try to tell everybody that give up cars, give up, try to walk, try to take the bike. It's not only good for the environment, it's also good for your own health. So you are not just benefiting the environment or the world as a whole, you are benefiting yourself too. So it's
excellent. I'm not going to disagree with you in any way, but yeah, that's excellent. If one last question, imagine somebody was listening to this, was an aspiring researcher, or a young person in school, or an old person not at school but maybe thinking about things. and they wanted to maybe get involved in science, technology, in anything, have you any bit of advice for them?
Just keep an open mind. Question everything. If Einstein wouldn't have questioned theories that was propounded by Newton, we wouldn't have quantum physics. We will always have a classical world. We wouldn't have even dreamt about a different world that sits inside the classical world. Now, so I have been challenged before by other researchers. Why are you questioning this? Because this norm and this law has been set for years and years. But I think the main aim of being a scientist is to question everything, even question that whether the earth is round or not, whether it revolves around the sun or not. So question everything, go back and reiterate. So each time we had groundbreaking discovery, it has always been going back and questioning what was set up there. So it's just keep an open mind. You don't have to take anything for granted. I think that's what I would say.
It's words to live by. Indrakshi Dey, thank you so much for speaking with me today. It's been I've really enjoyed it. I hope you know that. I'm going to put some links in the show notes, links to your profile, links to some of your recent works. So if you want to find out more about you, you can do that. But if somebody did want to find out more about you, is there any one particular place you'd recommend that they go?
Just put my name in Google. There will be multiple pages coming up.
Okay. Excellent. Indrakshi Dey from the Walton Institute, the manager of the Programmable Autonomous Systems, or the head of the Programmable Autonomous Systems division at the Walton Institute. Thank you very, very much.
Thank you.
Thank you for listening to this episode of The Machine. If you enjoyed it, please leave a very kind 5-star review wherever you listen to your podcasts. And we'll talk to you soon.